Houston is the fourth largest city in the United States and the largest city within the state of Texas. Houston's economy has a broad business base, only second to New York City to more Fortune 500 headquarters in the city limits. Much of the city was built on forested land, marshes, swamp, and prairie, which are all still visible in surrounding areas. Flatness of the local terrain when combined with urban sprawl has made flooding a recurring problem for the city. Downtown stands about 50 feet above sea level, and the highest point in far northwest Houston is about 125 feet in elevation. Houston's long-standing nickname, the Bayou City, was adopted largely in part because of the Buffalo Bayou, the major bayou that runs from the western outskirts of the city eastward. Buffalo Bayou is the largest primary stream within the watershed and also the sole outlet for the Addicks and Barker reservoirs. Addicks and Barker reservoirs were constructed to protect areas downstream along Buffalo Bayou in downtown Houston. The bayou flows into the Houston Ship Channel, passing through downtown Houston, eventually draining into the Gulf of Mexico. It is estimated that the Addicks and Barker reservoirs will prevent average annual flood damages of $16,372,000 to the city of Houston. Both Addicks and Barker reservoir outlets experience tremendous volumes of rushing water to control the drainage of the city. Both outlets have served Houston and the surrounding areas faithfully for over 60 years. The constant outflow and pressure that volumes of stormwater present on a year-in, year-out basis will start to create small, weak erosion pockets around the outlets where friction from the forceful flow of reservoir water is greatest. From this point, the eroded area around the drainage gates begin to increase, washing away the subbase around the outlet structure. Developed voids increase and make way for water seepage, which creates an underground flow of reservoir water. Numerous water seepage locations will continue to weaken and erode the soil, creating even larger voids, not only horizontal to the structure, but vertically as well, creating safety concerns for the performance of the outlet structure. In the spring of 2009, heavy rains caused both reservoirs to rise, which led to the flooding and closure of major roads into Houston. To err on the side of safety, the Army Corps of Engineers issued an urgent and compelling status, allowing the Army to begin the outlet restoration process immediately, a decision that would ensure the safety and performance of the outlet structures for the city of Houston. Due to the urgent and compelling status, the Corps chose Eurotech ICR, a soil remediation company that specializes in stabilizing weak base soils under heavy concrete structures using a special high-density, hydro-insensitive expanding polymer.
Life vest just in case the dam breaks and water comes rushing down. We pull the deal and
gotcha. What's this
for the
deal
best.
right here?
Little CO2 cartridge, it blows up
Gotcha.
when you pull the cord.
You guys ready to rock and roll?
Fixing the beam.
All right.
With Eurotech operators ready to go, the void filling process begins with Addicks outlet being the first to receive treatment. Ground-penetrating radar results identify where void spaces are located. Based off the GPR results and instruction from the Corps, Eurotech drills injection holes to begin the process of stabilizing the outlet structure. After the first injection holes were drilled, Eurotech operators discovered larger void spaces under the conduit that was initially suspected based on GPR results. Operators field tested the void spaces by inserting a 5-foot copper rod through the 24-inch thick concrete. Void probes showed 1 to 3 feet of void in many areas under the conduit. As the injection process began, large void spaces began to fill up, along with densifying and reducing seepage. As the polymer is injected, it immediately starts to expand but still travels under the conduit to the path of least resistance, filling the void and densifying weak areas.
So far we've finished tube 1, starting on tube 2, working our way toward the middle.
How are the voids underneath the tunnel?
1 foot, 3 foot.